If you have any doubts on this topic, you can ask me. Any doubts? Give the reply fast. Just wait a minute. So today it's all the last problems on this topic, and when you come for the new problems, I'll solve it then also. Next question. Suppose a solid has a cubic structure. Solid has a cubic structure in which X atoms are located at corners of the cube by atoms are at the cube center and O atoms at the edge center. Find the formula of the compound. Find out formula of compound. Just try to find the answer. What they say, one solid is there which has the three different types of atoms, X, Y, and the O. X atoms are there at the corner, and the Y atoms are there at the body centered, and the O atoms are there at the edge centers. Then with the help of this, what is the formula of the compound? Do it first and tell me the answer. What is the answer? Anybody got the answer? Give me some reply first. Preeti, Jafar, Ramcharan, Shruti, and Vishwanath.
Sir, XY2O3.
XY2O3.
O3. Yes, sir.
Any other answers? So if you take the X atoms divided the corners, how many corners will be there? 8 corners will be there, and each one will contribute only 1/8. That means X equal to only 1. And if you take the Y atoms, Y at the body center. Okay, so body center means what? Only one atom will be there at the body center, and this one atom will also completely belongs to only one unit cell. So Y also 1. Next O. O at the edge centers. How many edge centers are there? Total 12 edge centers are there, and each edge is shared with the 4 other unit cells. So how much total from this? 3. Okay, so when you combine all the things, you get the formula of X, Y, O3. This is the answer. Is it clear? Read the question properly. X atoms are located only at the corners. Okay, 8 atoms into 1/8, and Y atoms are located only at the body center. Y atoms at the body center, so one atom completely belongs to the only one unit cell, and O atoms are there at the edge centers. Okay, so 12 edges will be there, and each one belongs to 1/4 part only. So that is the 3. So that is the formula. Any doubts?
No, sir.
Can I go for next one? The next question is, potassium crystallizes in a body center cubic lattice. What is the approximate number of unit cells in 4 grams of potassium? What is approximate number of unit cells in 4 grams of potassium? Atomic mass of potassium is 39. Tell me the answer. They said like potassium crystallite in the basis structure. What is the approximate number of unit cells in 4 grams of potassium? So given weight is 4 grams and atomic mass is 39 grams. Do you know mole concept? Yes or not? If you want mole to particles, you have to multiply with the Na. Mole to grams, you have to multiply with the molar mass. This is a mole concept or not? Volume now, you want to multiply with the 22.4. Or if you want gram to moles, divide by molar mass. Particle to moles, 1 by Na, and volume to moles, 1 by 22.4. Okay. Now what is given? Given weight is 4 grams, atomic mass is 39 grams. Can you tell me what is the number of moles here? First, number of moles is equal to given weight by molecular weight. So given weight is how much? 4. The molecular weight is 39. This is the number of moles. If you want particles now, what I'll do? Number of particles equal to moles into 6.023 into 10 power 23. This is nothing but the Avogadro's number on the right, Na value. Okay. So what is the mole value here? 4 by 39 into 6.023 into 10 power 23. These are the number of particles, but each BCC unit cell will have 2 particles, right? BCC is equal to 2. If you take this as the number of atoms are these many, and each BCC unit cell will have the 2 particles. That means how many BCC unit cell will be formed? Anyone? Number of BCC unit cell of potassium will be, what is the answer? Number of particles by 2. Because 2 particles will be there for each unit cell. So number of BCC unit cell, how many? Number of particles by 2. That is equal to 4 by 39 into 6.023 into 10 power 23 whole into 1 by 2. Solve this one, you will get the answer. First, did you understand this problem? Did you understand the problem or not?
Yes, sir.
Then tell me the answer, please. Got the answer? What is the answer? What is the answer?
Sir, I got 308 into 10 power 20. Into 10 power 20.
Okay. You can write it as 3.08 into 10 power. No, the actual answer is 3.0 into 10 power 22 only. Please check it once again.
Yes, sir.
This zero is not come.
The zero is not there, sir.
Why not?
308.
Yeah, 3.0 into 10 power 20 only. Okay. So next, is it clear or can I go for next time? Or can I explain it once again? Remaining. Next question I'm writing here. So next question, what they have given. Gold has a closed package structure which can be viewed as a sphere occupying 0.74 of the total value. If the density of the gold is 19.3 gram per cubic centimeter, calculate the apparent radius of the gold ion in the solid. So if they're having the sphere occupying 0.74 fraction, now what is that meaning? It is the FCC structure. Understanding? They have given the packing fraction. So packing fraction is 0.74. That means that is a FCC structure. Okay. And density they have given as 19.3 gram per cc. With the help of this, you can calculate the apparent radius of the gold atom. See, FCC means what? Root 2a equal to 4r. You are want to find out the r. But what is the relative density formula? D equal to Z into m by a cube into Na. From this, you'll get the a value. Substitute the a value in the this formula. You'll get the answer. Understanding how to do the problem. But in that, they didn't give the molar mass of the gold. That you have to remember. Capital M value will be 197. Do that sum. First, find out the a value from the density formula. Did you understand what I'm telling? First, find out a value from the density formula. Then substitute that a value in the above equation, you get the r value. Okay, I will join within 2 minutes. Got the answer? The gold has a closed package structure, which can be viewed as sphere occupying 0.14 of the total value. Anybody got the answer of A? Just you can substitute the values here, nothing else. You know Z equal to 4 for FCC, and M value is already given, that is 197. NA value you know, that is 6.023 into 10 power 23, and density value already given 19.3. So substitute this value, so we get the answer. Density is how much? If you want A cube now, A cube equal to, from this formula, Z into M by D into NA. So what is the Z value? 4, M value is 197, and D value is 19.3, and NA value is 6.022 into 10 power 23. From that you will get the A value, A cube value. And if you apply the cube theorem, you will get the A value. What is this value? Any one of you can tell me the answer. So if you solve this one completely, you'll get the answer of A is equal to 4.07 into 10 power minus 8 centimeters. Okay, now we got the A value. In FCC, what is the condition? Root 2A equal to 4R. So already know A value root 2 into 4.07 into 10 power minus 8 centimeter equal to 4R. This 4 and this 4 approximately will be cancelled each other. So approximately R equal to 1 point root 2 value. Root 2 value is what? 414 into 10 power minus 8 centimeters. So only your calculation will play an important role in this. Okay. Is it clear how to solve this type of problems?
Yes, sir.
Today I'm doing the different types of problems, which is very important for the JEE. Is it clear or can I explain it once again?
Clear, sir.
Can I write the next question? Remaining Jafar, Neha, Ramcharan, Vishwanath. Okay, we'll go for the next question. See, if you practice the many number of questions, you can able to crack the exam. There are two different types of questions you should know. Next, an element occur in BCC structure. Already have done this problem, similar problem before, with edge length of 288 picometers. The density of metal is 1.2 gram per cubic centimeter. How many atoms does 208 grams of element contains? Clear this question? An element occurs in basis structure with edge length of 288 picometers. The density of metal is 7.2 gram per centimeter cube. How many atoms does 208 grams of the element contains? Previously, we have calculated from the atoms to the unit cells. Now we are going from unit cells to the atoms. Let's find out the answer. Any idea how to solve this type of problems? Or can I explain? See here, what they said, an element occurs BCC structure. First information is BCC structure. That means 2 atoms per BCC structure. Okay, edge length is given A value, that is a 288 picometers, and here they have given in the gram, so we have to convert into the centimeters. Okay, how to convert that one? 288 into 10 power minus 10 centimeters second, right? Okay, now if you do the volume of these cells, the volume of the unit cell, because A is the edge length of unit cell, right? If you take the volume of unit cell, what is the value? A cube. So already we have the A value, just we will find out the volume of the unit cell as 288 into 10 power minus 10 whole cube. So what is the answer for this? Two 88 into 10 power minus 10 whole cube. What is the answer? It's difficult to do the calculation part, right? But you have to practice these cubes and all. So this answer will be the 23.9 into 10 power minus 24 centimeter cube. Now, we know already density formula. Density of the solid is equal to mass by value. So if you want value only, what you can do mass by density, right? So already they have anything they have given here. They have given the mass 208 grams. Okay, so this is the volume of elements 208 grams by density is how much? 7.2. What is this calculation part? Tell me. Volume of elements, volumical density by mass, mass by density is equal to 208 by 7.2. What is the answer? 28.88 centimeter cube. This is the answer. So this is the volume of the unit cell, 23.99 in 10 power minus 24. And the volume of the elements will be 28.88 centimeter cube. Okay, suppose if you do the ratio of these two, you'll get the number of unit cells, right? So number of unit cells in 28.88 centimeter cube is equal to how much? 28.88 by 23.9 into 10 power minus 24. The number of unit cells in this value is equal to 28.88 by 23.9 10 power minus 24. That will be approximately equal to the 12.08 number of unit cells will be there in 10 power 23 unit cells. But each unit cell, how many atoms are there still? Each BCC unit cell, you have the 2 atoms. Each BCC unit cell, total number of atoms will be 2. The total number of atoms is equal to 2 into number of unit cells. Okay, which is equal to 2 into 12.08 into 10 power 23, which is approximately equal to 24.16 into 10 power 23 unit cells for the particles. Clear? So this is the way we are calculating the number of particles per the unit cell. First, what they have taken? First, they have calculated the volume of the unit cell, that is equal to a cube equal to this much we got. Next, they find out the volume of the elements. So density equal to mass by volume, or volume equal to mass by density. 208 grams contain how many elements? 208 grams which by density equal to 28.88 elements will be there in the 208 grams. Now it's known number of unit cells now, just the number of elements to the total number of volume of the unit cell. That will be gives us to 12.08 into 10 power 23. And each BCC unit cell will contain the 2 atoms. So total number of atoms equal to Z into total number of unit cells. So 2 into 12.08 into 10 power 23 will give 24.16 into 10 power 23 particles. Clear? Any doubts in this? Any doubts? You will play fast. Any doubts?
No, sir.
Okay, next question. NH4 crystal, NH4Cl crystallize in BCC lattice with a cell distance, unit cell distance of 387 picometers. Calculate the distance between the oppositely charged ions in the lattice. What is the answer? Yesterday we discussed it, right? This one, the relationship between the distance D and the A in the case of BCC. Anybody remember the formula? Direct formula I said to you. In the case of FCC, it is RC plus RA equal to A by 2. In the case of BCC, what is the formula? RC plus RA equal to root 3 A by 2. Just use that formula to get the answer. Radius of cation plus radius of anion equal to root 3 A by 2. So already you have given the unit cell. This value they have given already. Edge length. So R plus plus R minus equal to root 3 by 2 into 387. So what is the answer? Tell me the answer finally. What's the final answer? This is 1.732 by 2 into 387. So if we solve this one, we'll get the answer of 335.15 picometers. Okay, this is the answer for this solution. So this is a problem also we discussed yesterday in class. I mean the formula for this. Okay, so with this we'll end the class here. Okay, I'll give you one homework sum today. You just solve it and tell me the answer in the next class. Iron occurs as DCC as well as FCC unit cell. If the effective radius of an atom of iron is 124 picometers, compute the density of iron in both structures. Okay, take the screenshot of this and tell me find out the answer and tell me in next class. One is enough. Can I give you one more problem? Okay, solve this one and tell me the answer. Okay. Fine. I'll end the class here itself.